next lecture from the given title, that is what? Electric effect of? Yes? Effect of electric current. Okay. So in our previous lecture we have already discussed about the current, electricity and nature of conductor. Okay. So now here, so we again recall the previous thing what we already seen. Okay. So let me finish first of all. What do you mean by electric current? We know a flow of charge. A flow of charge through a particular conductor. That is what? Yes, electric current. Now here we see the effect of that electric current. As we know in our earlier standard we have already seen, suppose here we are having a conductor, current carrying conductor. Here when a current is moved through that conductor, then some kind of field is generated around that conductor. Okay, all over the all direction of that conductor, and that field is called, yes, and that field should be perpendicular to that conductor. Keep remember that field, it should be perpendicular to that conductor, and that field is called what? Yes, yes, electric field. That field is called electric field. Okay, and it will be denoted with the help of E. When it becomes vector E, whenever we have a specific direction of that electric field, then we call it electric field intensity. Electric field intensity. Okay. Now go to our actual content. That is what here. Can you recall how do we decide that given material is good conductor of electricity or is an insulator? How we decide? Suppose we are having this marker. Is it conductor? This marker is a conductor of electricity?
No.
No. Why? Because of, if we try to move electric current through this marker, then it can't move. Why? Because of it is an example of insulator. It is an insulator. समझ में आ रहा है? अगर मैं कोई मेटालिक कंडक्टर ले लेता, मेटालिक मटेरियल अगर होता, तो मेटालिक में हमने देखा है जो गुड कंडक्टर्स है, एक है कॉपर और दूसरा है एल्यूमिनियम. ओके, ये दो हमारे गुड कंडक्टर्स है जिन्हें हम प्रैक्टिकली भी यूज करते हैं. बट इंस्टेड ऑफ कॉपर और एल्यूमिनियम, इफ वी यूज दिस मार्कर, ये प्लास्टिक से बना हुआ मार्कर है, इसको अगर ले लूं तो कंडक्टिविटी मिलेगी मुझे? नहीं, चार्ज मूव नहीं कर पाएगा. ये क्यों नहीं कर पाएगा वो भी देखा था कल. कैसे देखा था? किसी भी मटेरियल का, वो इंसुलेटर हो, कंडक्टर हो या सेमीकंडक्टर हो, क्या बोल रहा हूं मैं, वो कंडक्टर हो सकता है, सेमीकंडक्टर हो सकता है या इंसुलेटर हो सकता है. Conductor, it means what? A good conductor, for example copper and aluminium. Semiconductor means what? We are having another one material, that is what? Semiconductor. These are what?
Conductor.
Yes, these are conductors. Okay, and now semiconductor means what? Silicon or germanium. These are the two pure semiconductors, silicon and germanium. Now third is what?
Insulator.
Yes, insulator. It means what? It may be wood, it may be glass, it may be plastic, it may be rubber. Okay. Now here see the energy band gap structure of each. Okay. We'll finish it shortly. Okay. Here suppose we discuss about the conductor. We discuss about the conductor. Now here is the first band, that is called, yes, valence band. The first band is what? Valence band. If we are talking or discussing about conductor, then here valence band and conduction band are overlapped. There is no gap between them. There is no gap between valence band and conduction band. It means what here? Easy means
Example.
forbidden. Yes. क्या बोला तू? Forbidden energy band gap is what? Zero. Here. Easy means what? Forbidden energy band gap. So Eg is equals to what? Zero. In what? In pure semiconductor. Sorry, in pure good conductors. Okay. If we see the Examples of good conductor like a copper or aluminium. In a copper or aluminium, the gap between valence band and conduction band is what? 0. The gap between valence band and conduction band is 0. Means what? When we observe the energy band gap structure, then the top of the valence band and bottom of the conduction band, top of the valence band and bottom of the conduction band, they are physically touched to each other. Means they are overlapping each other. Now here see, if you observe it, then this is a top of valence band and now this is what? Bottom of conduction band. These are completely overlapped. Okay, due to that overlapping or if forbidden energy band gap is 0, here if I want to give the charge to the valence band, then due to that charge here, already number of free electrons are available, but due to the charge, these free electrons get excited and they want to go somewhere. They really want to leave valence band, and there is only one place for them, that is what? Move from valence to conduction. The atomic structure of this mechanism is like, suppose we are having a copper atom. This is what? Nucleus, and this is the outer orbit of copper. Assume here there are the 8 electron already, okay, in a copper. 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are the 8 electron. Okay, suppose here this is a valence band. Why? Because of there is the number of free electron available as per the Newland's rule. Okay, now after that, giving a charge to that valence electron or free electron, these electrons get excited. And they move from valence band to conduction band, means lower level to upper level. And here is our conduction band. Okay, the charged electrons move from valence to conduction, or when electrons are reached at conduction band, then that atom is able to share a charge with neighboring atom. तो एटम से जर चला चार्ज देण्यासाठी रेडी होत जातो. जिस एटम के कंडक्शन बैंड में इलेक्ट्रॉन चार्ज लेकर आ जाते हैं, वह एटम उसके निकटतम एटम को एनर्जी देने के लिए सहकार्य करता है. ओके, लीव इट. अच्छा हो गया, हिंदी भी आ रहा है. वाह, ग्रेट. तो रुको थोड़ा. Then we'll see the next one, that is what? Semiconductor. Okay.